Hello everyone, today I'm going to explain 5 CCNA rescue questions. Let's start with the first question. The question says that R1 has learned all routes via OSP fault routes learned by R1 through the OSPF protocol. Which command can be used on this R1 to configure a backup route? R3 is reached via R2 and R3. This one, 192.168. So how does this path go? That's what is being asked. Taking this path means that this route is obtained through R2 and R3. So our correct answer is A, option A. It writes a route to the 20.0.0.0.0 network. And which way does it go? It goes via 30.0.0.0.0. 3. It goes via 30.0.0.0.0, specifically 30.0.0.0.2 for this 30.0.0.0.0 network. On my side is 0.1, on the other side is 0.2, right? So just set it to go this way, and that's it. After that, write a route with a higher value than OSPF, because the main path in the middle is OSPF, right? When it goes down, mine is also a floating static route, which means I need its priority, that is its AD value, to be higher than OSPF's. Just set it a bit higher than OSPF. OSPF's AD is 110, so we just need to set this to 111, right? The correct answer is A. Let's look at the correct answer. Cool. Alright, question 2. The second question is about the OSPF election process for DR and BDR. This is about making router 2.1 act as the other router, which means this one. It just acts as another router. It can't be elected as DR or BDR. It can be elected as DR or BDR, which means either it withdraws from the election or you raise its priority a bit to let router 3 become DR. Just let router 3 become DR and that's it, right? Now, let's take a look at this. Who is the DR? Which one is it? Looking from 2.1, the DR is now 3 and the BDR is 2. So, then what does it mean? It means we want to make 2.1 become the DR. Now, we know that the DR election has 2 criteria. The first is the priority. Yeah, a bit urgent. The second criterion is the router ID. Now, since we haven't set the priority, router 3 has the largest router ID, right? So it was elected as DR. Router 2 has the second largest router ID, so it was elected as BDR. So now, if we want router 1 to become the DR, we just need to set its priority higher. And that's it. But after configuring it, since this role is non-preemptive, the DR role cannot be preempted, and the BDR role also cannot be preempted. So we need to restart. We need to restart the OSPF process on routers 2 and 3. So the correct answer. What is the correct answer? Who should we choose? Actually, it's not this one. It's not B. The correct answer is D. Right? Set its priority to 200 and then restart the OSPF process on router 2 and 1. Actually, that's not entirely correct either. You need to restart the OSPF process on all 3 routers. But since the answer given is D, we'll just choose D. The correct answer is D. Alright, next question. Which plane in SD-WAN is responsible for traffic forwarding? This one's very simplest. The data plane that handles traffic forwarding. Management, control, policy, and the data plane is responsible for forwarding traffic. Okay, next question. Now, for this question. let me take a screenshot of this question first. The meaning of this question is that a program starting from, say, this server for 300 users is being scaled up. So from a server for 300 users, it's being expanded to 600. That is, it's being scaled from 300 servers to 600 servers. And each server needs 3 network connections to support production. Then there's backup. So there are 3 types of networks: production, backup, and management. 3 types: production, backup, and management. Each connection is located in a different subnet. So first, you need to use this network segment 10.0.0.0.0, an 8-bit network segment, meaning the subnet within this network. So this is about generating this routing configuration. Which configuration on the router's interface must be set to meet this requirement and minimize IP address waste, right? Basically, we can expand the original route, just expand the subnet a bit. Here, we're using the CIDR technology, which is called classless interdomain routing. It means borrowing bits to the left, borrowing network bits to the left, and expanding the original subnet, right? So by expanding it, it becomes a 23-bit subnet. With 23 bits, this group here becomes a 23-bit subnet, which means you get twice as many IP addresses as before, right? So the correct answer is to choose A. Let's check the correct answer. Choose A. All right. And then this one, question 5. Question 5. It asks, which interface sends traffic to 192.168.0515? For this question, the correct answer is C. It definitely matches the static route first. This 192.168.0.0 diagram isn't very clear. What it means is this. It first matches 192.168.0.0. This is a 24. Why is that the case? Because of the longest match rule. Please pay close attention here. There are 3 distinct routes shown below. I will now screenshot this diagram for your reference. This diagram isn't very clear. There are 3 routes below, learned from 3 different protocols. One is a static route, one is OSPF, and one is this one, EIGRP. So with these 3, let's look at the subnet mask links. One is 16, one is 23, and one is 24. It will definitely match the static route, right? Because of the longest match rule. Then the next hop is 10.0.12.2. Then this process will perform a recursive lookup. It will check how to reach 10.0.12.2, and it will recursively find this directly connected route, then determine the outgoing interface. G 0 to 1. That's the interface, right? So that's how you arrive at this answer. G 0 to 1. Let's check the correct answer. Alright, submit. To learn Cisco technologies or access question banks, message me. For technical discussions, comment below.